to yesterday, I can't just remind you that I was writing this and I said this electron spends most of their time on oxygen. They spend most, and then carbon is almost positively charged. Like that. I've written them this way for you yesterday. That carbon is almost positively charged. So the positively charged carbon will in turn pull electrons away from the alpha carbon. From the alpha carbon. The alpha carbon itself will pull electrons from the alpha hydrogen. And I did tell you that I know why, and I said resonance, the more the resonance structures, the more the... That's what you should have known, have read overnight for today. Not say I will read it over the weekend. No, I will not be there. I drink alcohol over the weekend. I do nothing with chemistry. So now when you look, the alpha hydrogen, if you remove it, you are forming a primary carbanion, and it's less stable. It will react fast to form the product. So the base will whenever the base will only deprotonate fast, the alpha side, and that reacts. It has no chance even to go to the alpha prime. It has no chance because it's sterically in that lithium diisopropyl amide. So what I said up to now is that thermodynamic factors involve high temperature. Dynamic means reversible. And then you are using a less bulky base, and the product is formed from the more stable intermediate. In that case, the more substituted enolate ion. And it's not only enolate ion, because you can also have it under acidic conditions. Still, you have the more stable and the more substituted enol. The more substituted enol is the one that will be favored. Don't think that it only applies under thermodynamic or only on enolates. No, even other reactions you do them that way. The only reason is that you have to use the temperature differences. One is reversible, the other one is not. And then the thermodynamic conditions, the product resembles the more stable intermediate. And under kinetic conditions, the product is from the most reactive species. Reactive side. So it is the alpha side. Are we together, Madame? Next question. If you don't have a question, you can comment. On which day are you writing? Is it next week or the week after next?
Next week.
All right. Thursday, Friday?
Thursday, I think.
Guys, I think I've covered most of the things. I've covered the whole syllabus. Anyway, most of the things is just revision, and anything at honors is a combination of first year, second year, third year. We're just only applying this on together. We integrate, they are interrelated here, we integrate them. Whereas at first year, you did one group alone, one group together alone. At second year, we started reasoning about resonance, inductive, steric hindrance, more of this, kinetics, thermodynamics, and then we were orientation at second year. Third year, we started combining. We introduced vertex a little bit. Third year is just, honors is just almost the same thing except few additions. But the tricky part, which is not that difficult, is that you look, there are many functional groups within the same molecule. Yours is to know how each one behaves and take it from there. Any question?
No, thank you.
We stop here. Any comment before I leave? Any comment?
Oh, just one question. When you write in the exams, we should always go resonance structures, right?
You should only go what?
Is it preferable to always draw the resonance structure?
It's not preferable, it's a must.
It's a must, okay.
Yes.
Okay.
It's a must. Yesterday I explained, maybe you're not in yesterday, I explained that if you draw the resonance structures, one of them You will notice, in fact, even in the enol or enolate, you must check enol or enolate. This way. Let me show you one thing, because I can say, I foresee something there. What you said, what you just said worries me. Let's take the enolate ion. And then it was C, maybe CH2, negative, and then the other side CH3, whatever. And then I said to you, this is an enolate. There's H2 here, CO. Just to bring back what we discussed yesterday, negative. And then I call this structure here, I call it A. And this other one, I call it B. According to yesterday's discussions, which one is the most stable between A and B? What we discussed yesterday doesn't change. It's more important even today. It doesn't change. And it was important the first day you joined this class. And it will be important in the exam, even when you exit the class. Which one is more stable? I took my time on this yesterday.
A.
Why? Why?
All atoms meet the noble gas state.
Yeah. Correct. No, wait a minute. I drew it wrong. Sorry. There's something that I did not draw correctly. I think there will be a plus here. We agree. There must be a plus here. Sorry. So all atoms meet the noble gas configuration state. You agree? Whereas in B, the middle carbon is not in octet state. That's why we are pushing electrons. That's the reason why we are pushing these electrons over here to make this region, this electron poor region, satisfy the noble gas configuration. Hydrogen has got each hydrogen has got 2 electrons, carbon 8, here in the middle, oxygen also 8. Here it is 8, 6, 8, 6, 2, 2. You see, when I said, don't forget anything I taught you from yesterday, it's more important than what we are doing now. So resonances are important. As resonances can guide you, they can tell you which part reacts. And you can write them fast because it's just the reverse of the other. I mean, to write this resonance won't take me a second because the only thing I know is that I pushed on the electrons to there to form a double bond. The rest of the parts remain the same. I only introduced a double bond here. So why should I take an hour writing a simple thing like that? Simple like that. Any comment? The question paper is 3 hours, 100 marks. There's spectroscopy, there's retrosynthesis, lots of mechanisms. I'm sending it to the external examiner today, in fact.
Are we allowed like any reference materials?
No. No. It's not an open book. It's not an open book. And even if you bring a reference material, I don't think it will help you. You need to read, guys. I've not repeated any question from the assignments. Believe me. But I've not deviated from the style of asking questions. The concepts are that way. But no, not that you're just going to say, let me check solutions from assignments. Never. They might be related, but you can't copy and cut and paste. You have to understand. Hello?
When I was asking about reference, I meant like reference material for the spectroscopy, like tables where bands occur and that.
No, I'm not attaching. I've not attached that. But even if I was to attach it, you see the problem when I attach it, I've got to make the question more complex.
Okay.
That's the thing I've got to do. I will do, and then now it's basically. I'm now going away from testing understanding because if I say carbonyl group aromatic is 7 to 8 and I've given a table of 7 to 8 really, I'm defeating the purpose. So I have got to complicate it, then I'm disadvantaging you. It's like a periodic table. What do you need a periodic table for in the organic chemistry? We're only dealing with 7 atoms. Hydrogen, carbon, nitrogen, halogens, if you take them as one, and then phosphorus, sulfur, silicon, and nitrogen, or boron. That's less than 10 atoms in a periodic table. Attaching it, it raises expectations. I always tell my students to say, even lecturers, I discourage that. I'll tell you the reason why. You put a lot of tables, the student keeps on checking. I mean, you believe that they are useful, only to find none of them is useful. If I was to include something, if I was teaching general chemistry, I will say, if you calculate empirical formula, I will say, this molecule is this, and I'll put C. I'll put the alphabet C, the AZ one. You remember the is it ANZ? So I'll put the molecular weight, I'll put the atomic weight, I'll put X there, SC. And then if you know that you are going to use 12 instead of 6, that's an understanding. I'll put it in that question so that you don't search, you do the correct things. Most of the tables in PhysChem or formulas I've encountered in PhysChem were not relevant. And I wasted time thinking that I should use them. And you end up failing. Simple things, I told you how to do that. Where you obtain those, you probably can take your notes there because I don't see you. But really, I want to attach reference material. And even if you use a textbook, it will waste your time. You'll take 10 minutes reading. When you come back to the question, you realize this is still a lot of work to go. And then you'll become, anxiety will increase, you'll be confused. The best is to read your work, understand it. If you understand the basics I taught you, you should answer any question you have not seen before. You should be able to answer it correctly without seeing it before. But if you don't follow Lewis structures, electronegativity and bond polarity, then understand the flow of electrons, that where you left and where you end up, there are changes. It's like when you throw a javelin, or even, let's say a javelin, you take it as an arrow. When you throw it, you'll definitely cause some changes on the surface. And where it ends, that javelin lands, it causes something. So you must account for where you started and account for where you end up. And don't make many arrows. Better have, once your arrows jump 3, something's wrong. You only use 3 arrows at the same time for Diels-Alder reaction, mass spectrometry, and what you call that, McLafferty. The rest is 2 arrows. Either you attack, the other bond breaks. Or you attack using 1 arrow to form a bond. You can't form 2 bonds at the same time and break 1. No. Step by step, you either break a bond and form another. Not many arrows. Step by step and not make any mistakes. Any other comment? And in the exam, start with the easiest questions. Don't try to answer them sequentially so that you save time. As long as you number them correctly. Not only in the organic, in any paper, as long as you number them correctly. Don't open gaps. You may not have time to come to blank spaces. Start with the ones that you understand, then focus later on the ones that challenge you. If you leave spaces, 3 pages blank, you'll never come and fill them. You are not going to. And they also increase anxiety and confusion. Answer those you understand first, and then end up with those that you think are difficult. And what I used to do myself was not to open all the questions. I opened question 1 and attempt everything under main question 1. Maybe leave those that I don't master for the later part. Because if you open the whole question, you realize one of them, you saw it in your notes but did not read it, it immediately confuses your mind. It locks up the long-term memory, and then you may not be able to perform well. But I've got the confidence in you guys. If you go and read, I was listening when we go on, but I wanted to hear all of you singing the same song. I believe others, you just did not want to spoil me by exposing me to your voices. But if you follow this note, go and read, and note that when I said first year knowledge is required, it doesn't mean go and read like a first year, even first year, second year, third year. There are certain principles that were there. We use them at first year. How to move these arrows, we started at first year. They are not changing. What a carbocation is does not change in first year, second year, third year. A carbanion and factors that stabilize it do not change. And I said the more the resonance structures, the more stable is the species. And among the resonance structures, if you check, there will be one that determines the stability of the whole molecule. There will be one that has all atoms in noble gas configuration. That's the most important, is the most contributor among the resonance hybrids. Any further comments or we stop? Are you still there?
Yes, yes.
Yes.
Talk to me.
Our exam, how the invigilating system, how it's gonna be since it's online.
You won't cheat me because I know you. You are less than 40. I will see all of you at the same time.
So which
We're going to use
online
Teams.
thing?
We're going to use Teams and Iris.
All right.
Yeah. Iris was supposed to have used it in June, but the university they could not pay for the contract quickly. It was an urgent arrangement, and it needed legal experts to advise the university so that we avoid issues that are confronting people at the tender board and judge on those commission. We don't want to see ourselves there.
So so if you can't have Iris, then you can have Teams.
Yes. And
All
I'll
right.
see you. I'll be watching you. I will be watching you. You really reminded me of the song of, what do those guys called? Alalalali Long. What do they call? Not Israel Vibration, but they've got a name. Former members of that world. Yes. What can you say further than this?
I wanted to know if we are still gonna have another class.
No, when? To me, I planned this, and I said through popular demand we can, but when? It can't be tomorrow. I'm tired, really. Yesterday I talked from 9 o'clock to 1:30. Today it was from 9 o'clock to 1 o'clock. When I left here at Ramses, I just went to one shop. They sell all liquids. I bought the ones I liked, and on the way I was imbibing. I was tired.
One other thing, I just want to ask about the 3-hour PEP.
Yeah,
There is
plus
plus 1 hour.
No,
and
the
then
other time of
1 hour
of uploading and that's not what I've got time to. I can give you 15 minutes.
Okay.
Yeah,
So
but
it's 3 hours plus 15 minutes.
3 hours for writing. No, you can even use that additional one. Remember, if you don't understand anything, even if I give you the whole night, you'll still be battling. If you understand those things, 3 hours is too long. You see, unnecessarily too long. 2 hours you can finish. And read the questions, guys. Read the questions. I noticed that you don't read the question, you just attack it. When I was teaching general chemistry at first year in one university before, including UNISA, I used this question, I liked it. Give me five physical properties of metals in the test. They're shiny, they're malleable solids, shiny, good conductors of heat and electricity, and then I stop there. In the exam, I say, give me 5 chemical properties. I've changed. It's no longer physical, it's chemical. Somebody, solids, last child, 0, and somebody says Mphahlele phase, maybe, but you not read the question. This one does not say chemical, it says physical. That one says chemical. They differ. Read the questions. There's a question that unfortunately, if it was Monday, I'll remember, because I need to send it to external examiner now when I leave here. There's a question on batch reduction. There is retrosynthesis, several syntheses, 2 mass spectrometry, spectroscopy, this time around I made it simple. Very simple, so that you get that 10 marks. It's 15 or 10 marks. The spectra we're treating like today, so that you get all of them, you get all the marks. That's the only one that is not challenging. The rest, they're not difficult. They're not difficult at all. If you write the correct Lewis structures and you push from there, you should get all the answers correct. If you omit the Lewis structures and you don't know what moves, that's the disaster now. And notice one thing here. Notice one thing here. I'm sure you think that on this structure, let me write in green here. You think I'm moving the charge. No, I'm moving the electrons. It's just unfortunate I not want to start. If you have written them, both of them, I don't care, you can move from the charge. But if the electrons are missing, you're going to get 0. For those who were not here yesterday, just to wrap up and caution you, when I say Lewis structure, let me remove beta, gamma, and so on. When I say Lewis structure, we started this way. I said to my colleagues here who were there, I know some of you are not here. If you write this, you say H. Any person, including a child in a kindergarten, will say H. But once you write this, you include this. Somebody will say, there's an H and a dot on it. But you as a scientist, you'll say it's a hydrogen atom. And then I said again, if you write this, my grandmother, who has never been to class, will simply say hi. But once you write this, somebody will say, no, you join H and I with a line. And that person will still be correct. But once you write this, only a person with chemical background can tell what that is. You will say it's hydrogen iodide. The rest are not correctly represented. So that is what I was saying to you. And if you break this bond, hydrogen takes both, and I said this is a movement of 2 electrons. This part of the head is 1 electron, this part is 1 electron, which means 1 plus 1 is 2. And this is movement from a region of high electron density. These electrons move to a region of less electron density, like diffusion in biology. And then what's happening here is that H is no longer having electrons because both of them have been taken. Then its state is represented by positive charge because it has no more electrons. And I said to all of you, this is very important. This represents the west end. You and me. Otherwise, if you write it this way, it's 11. Whether you separate this 1, you put it here to there, I'll say it's 11. But once you put this, I'll say it's 1 and 1. So that's why it's important to do it correctly. And then now you go and write this I. Quickly, these electrons should be there. I've not done anything on them. Why should they be missing? This pair is there. I've not used it. Why should it be missing? The top pair is there. Why should it be missing? But I brought new one. And this must be now accompanied by a negative charge. That's how we do chemistry. Once those things are missing, you can't do anything. And I said to you, if you leave the 2 together, let's say here it is partner A and partner B, they divorce. If you leave them together, they'll reconcile. Reconciliation, the one who took more should bring back, and then the relationship goes back. That's what I was saying. If you just do this, there's no way you can make any mistake. Rest assured. There's no way you can make any mistake. Lewis structures, correct flow of electrons, account for the number of electrons on the left and right hand side. If you look at HI there in the green, there were 8 electrons, 6 around I, 2 in the middle of I and H. I check on the right hand side here at the bottom. All those 8 electrons are around I. I can account for them. And I can account for the letter H is here with a positive charge. And I can account for the letter I is here at the bottom. So it's balanced. So we have balanced the reaction. only electrons move. I told you that when you go to the shop, it's the money that buys, not you, not even your purse or your pocket. You have to take it out, give it to the shopkeeper or whoever is there. Only then will you get what you want. You can go there, put money in your pocket, they will not give you anything. It's not you who buy. It's not your pocket which buy, it's your money. You trade with banknotes or coins. Atoms trade with electrons. Maybe what I should show you, maybe so that you don't make a mistake, this arrow must move from these two electrons. Maybe you'll understand. That is not the charge that attacks. That charge, we only write it out are there. We don't write it before electrons. That is one tactic or strategy. Another question? Nani? Oh yeah, that group is inner circle. The ones that broke from third world. I'm a Rarian, so that I know these groups. I just forgot them because I'm thinking about mechanisms now. So are we done with your questions and comments?
Yes, sir.
Okay. Good luck. If I decide other way around, if I decide the other way around day, I wish I could do it on Saturday, but no one will come, nobody wants to on a Saturday. I stay in Pretoria. I will do it from Mokalek, Mandela, but I don't think any person to help me on that side. So if it has to happen, it will be Monday and you'll be informed. But feel free to send me emails with attempts any time of the day, whether it's midnight, as long as I wake up, I'll attend to you. But attempt it first. I'll guide you then. Don't give me another exercise. I'm not a student. You attempt it, I'll read it and I'll tell you what you should. There and there. Feedback in minutes if it finds me awake. But if I wake up, you'll get it before you wake up. Bye.